Good morning, Professor Mark. Today I will be going over my um, embedded systems project for milestone 5. And it's going to be an embedded snake. It's going to be a very brief overview of the entire application. We'll go through all the designs in with some of the functionality, and then finally we'll show a short video of the actual functionality of the whole application. So for a project overview, the original idea was to have a game of Snake. If you don't know what that is, it's a very old computer game where you have a three-segmented snake that you start out with, and you can control which direction it goes, and it works in a square grid, and there's going to be a piece of food on the screen, and so your goal is to operate the snake to get to that piece of food and consume it, which will make you one segment longer. However, if you hit yourself or if you hit any of the walls, then you will die. It will be game over. So you try to get your snake as long as possible without dying. Um, the whole application is going to be running on the Intel DE10 standard, which is a board from Intel that has a lot of peripherals. It's bigger than the Mini, and it can pretty much do anything that you would want to do with embedded systems. And that's what we're using for the class. So the actual kernel is running on a Linux OS. So it was really nice learning that. I hadn't worked with Linux before, only Windows and a little bit of Mac. And so actually getting some of that experience has really been helpful, especially with work, because I'm working with Docker and Ubuntu in there. The actual application running on the ARM processor is written in C, so we also learned the C programming language, which is a big jump coming from Java and from Python, because you have a lot more control over everything that's happening. With that control comes a lot more learning that you need to do, but a lot of the time that's a good thing. It integrates the FPGA, which is simply put a big logic circuit that you can reprogram to represent different circuits. And so in this, we have to integrate the FPGA to talk with our actual C program, and from there interact with the peripherals. Its project overview is going to display to the LCD display, which is just like a regular pixelated screen, and then the LED 7-segment display, which is just a number displayer. So it has 7 segments, so you can display 0 through 9 on it. It takes inputs from 2 of the buttons on the board. You could use whatever inputs, peripherals that you wanted. I decided to use the buttons because it makes sense for the game, because all you're doing is turning left and right. And this was just a whole introduction to embedded systems, how the development works, and just everything that goes into it, from taking an application from thought all the way through to implementing it and testing it, making sure that everything works and ending up maintaining it. So this is the system design. As you can see here, we have our main application in the C code running on the ARM processor on the board. So your C code, the C code is actually listening to the 2 buttons, the left button and the right button. So anytime those are pressed, the C code is reading those, because it's just pulling for them constantly each loop. Every time it goes through the loop, it's also updating the LED display with any changes of the snake position, new food if it's been eaten, and then also if there's any text, like a game over text or anything. And in the ARM, the C code actually sends to the FPGA. So the C code doesn't interact directly with the 7-segment displays. It actually sends 4 inputs actually to the FPGA, and then from there the FPGA is going to talk to the other outputs. So this is actually the application design. So the C programming, we'll start here. So it starts in main, it displays a welcome message, displays 0 to the 7-segment display because your score is 0, obviously, because that's what it's used for. It creates the starting snake in the middle of the screen, and then it asks you, like, it displays the welcome message, and then it asks you to press a button to start. Once you press the button, it sets the direction of the snake to the right, and it generates the food on screen. From there, it just goes through this whole loop where it checks if you hit a wall or if you hit food. If you hit a wall, it ends the game. Obviously, you're not that good at it. And then it asks if you want to play again. If you do, then it goes all the way to the end. Otherwise, it just ends. If you hit snake food, then it's cool. It generates a new food on the screen, somewhere random, and increases the length of your snake. And it also updates the score on the 7-segment display. And then if you didn't hit the wall and you also didn't hit a food, then you just moved, so it just updates the LCD display. Um, and then it checks whether you press button 1 or 2, and then it changes the direction from there. So pretty simple all in all. It took a while to make it that simple, but we'll move on to the VLSI design. So this is actually the architecture for the C application connecting to the FPGA, which is right here, and then the FPGA connecting to the 7-segment displays. So basically how it's going is a C has mapped 4 inputs pins to the user space of the C program, and we can manipulate those from the code. And then depending on what is in here, it runs it through a 7-segment decoder. So if you enter 1, then it'll only it'll go through the 7-segment decoder, and from there it'll know which segments on the 7-segment display to display 1. So it goes from 4 from the architecture in the center of the FPGA design. It'll turn that into 7 outputs, which are output pins here because there's 7 sections of the 7-segment display, obviously. And it'll decode what it needs to put there, and it'll go write that to the LED display. Next is some functionality, so the user can see the game on the LCD. The user can press button 1 to turn right, or button 2 to turn left. The user can also see their current score on the LED display, which is the last step with the FPGA. If the user hits a wall themselves, they will die. Right now, it actually is pretty easy for a while, because there's just a huge screen and the snake's pretty tiny, so that could be something. Once it gets near the end, though, it gets pretty freaking tough. The user can also replay if they die, and this because you do die quite a bit. And the snake will get longer each successful eating, so it'll actually increase the length of the array and do all of those calculations as needed. So how was it designed? I guess the biggest thing to start with is some of the issues that I had to work through. So one of the biggest ones was figuring out how to track the array for snake positions. So I didn't want just like one array that starts here and it just infinitely grows and grows, because that's not applicable. So I had to figure out a way to reset the snake array if anything happened. And how I did that is actually I track the head of the snake, and I just replace the head of the snake with the oldest, like the new head for each time it moves, assuming it doesn't hit anything. It just replaces the oldest body part in the array with the new head. So it's not actually moving, it's just removing the old one, popping the old one off, and then putting a new one on the front. So it looks like it's moving in real time, but it's actually just popping the old one off, putting a new one, just consistently doing that. The next issue is mapping the snake's positions to pixel positions for the display. So if I did it 1-to-1, then it would be literally impossible to see the snake pretty much, because it would just be very, very tiny. So what I actually had to do was map it to 3 times bigger. So each actual pixel in each section of the grid in the C code is a 3x3 grid on the actual LED display. And so because of that, the borders look a little wonky because to make it line up right, I had to increase the width of some of the borders. The next thing was encapsulating all the hardware functionality into its own class. So actually separating, which is a big thing that Professor Riha pushed, is that separating all of your face code to all of your peripheral code. That way, if you ever decide to change peripherals, you can just pop it out of that method, put it in, and you don't have to change any of the rest of your code. The other thing is how design is a game loop, so all games really run just like one long while loop to where it goes and it makes all its checks and to see what the player has done, and then it moves on. So like if you're running 60 frames per second, your game is going to be iterating through that loop 60 times in every second. And then for the future, some of the things I want to implement is a high score. So writing a high score to a text file, and anytime you start it up, then it's actually going to go read that text file and display it. So it'll say, "Hey, this is a new high score," and if you beat that score at the end of the application, it will go right to that. And then maybe move to an external display, like with an HDMI or cord or something like that, to a bigger display, so it makes it easier to read. I'm going to end with a functional demonstration. Go and watch it. So it's just booting up. It's welcoming you to the game. Press button to start. From here, you're eating the food. You see the score is 1, and then we're going to go hit the next piece of food, and it will increase to 2. We'll actually go eat 2. So it's going to go leave 4, or 3, I mean. Oh, we're going to eat another one. So the score is actually going to be 4. Yep, go look at it. I'm going to run in the wall, show game over. We'll press 1 to end the game, and that's about it. That's all I've got. Thank you so much. It's been an amazing semester, and I've learned so much. Have a good rest of your night.